So what we're looking at here are the elimination reactions of alcohols. We can take an alcohol, we can remove the OH from one carbon and a hydrogen from the carbon next door, forming water. So we can also call an elimination reaction dehydration. We're removing a small molecule. We are eliminating a small molecule from our organic structure. We need an acid catalyst to do this. Typical acids would be phosphoric or sulfuric acid. So if we were to take ethanol, all that is happening is the OH is being removed from one carbon and a hydrogen is being removed from the carbon next door. We introduce the carbon-carbon double bond between the two carbons and we eliminate water. We have dehydrated the alcohol. Pause the video and have a go at questions 1 and 2. Okay, we don't have to draw out displayed formula. We could do it skeletally. Propan-1-ol, prop and 1-ol is going to, we're going to remove the OH group from this carbon and a hydrogen from the carbon next door. So we will form propene and we'll form water. If we take cyclohexanol, cyclohexanol, we're going to remove the OH from this carbon and a hydrogen from the carbon next door. It doesn't matter which side we take it from because these are identical carbons. The cyclohexanol forms cyclohexene and water. It becomes more interesting when we have a molecule such as butan-2-ol, because this time when we remove the OH group we can take a hydrogen from carbon number 1 forming but-1-ene, or we could take a hydrogen from carbon number 3 forming but-2-ene. But when we form but-2-ene we have to think of stereoisomers. So dehydration of an alcohol is a real opportunity for examiners to give you a structure where we could form structural isomers, but-1-ene, but-2-ene, and then also we need to think about stereoisomers, E-but-2-ene, Z-but-2-ene. Another reaction of alcohols is substitution. Substitution, if we remember, is where one atom is replaced with a different atom or atoms. So in this case, propan-1-ol, what I'm going to try and do is swap the OH group for a halogen. In this case I've chosen chlorine. Now to do that we need to think very carefully about the reagents and conditions. This is something that you really need to learn. It's not many marks in an exam, but it is a typical exam question coming up almost every year. To make this happen I would use some sodium chloride if I'm trying to replace OH with chlorine. If I want a bromine I'd use sodium bromide. I would also use some concentrated sulfuric acid. This will work for any alcohol. Cyclohexanol, if I react that with my sodium chloride in the presence of sulfuric acid, I'll end up with that substitution reaction occurring. Really simple, straightforward, but it's something that you really need to learn. It's often tested in a flowchart question.